Hello everyone. Today I am going to discuss the last problem of AtCoder beginner contest 358, which is AtCoder tool. So what is the problem? We are given a grid with H rows and W columns. Takahashi starts from cell Si, Sj and repeats the following action k times. He either stays at the current cell or moves to an adjacent cell. After this action, if he is at cell I, j, he gains a fun value of ai, j. Okay, so he can either move to any adjacent cell, but he can't move diagonally. He can move left, right, up or down. Okay, and we have to find the maximum total fund value he can gain. So let's take one example. Let's take this example only. Let me copy this thing. So okay, uh, so this means that he has two rows and three columns. Two rows and three columns. So the first row has 2 1 2 and the second row has 3 4 5, and he starts from the first row and the second column. Here the this is given in one based indexing. So first row and second column. So he starts from this. Now he can move three times. So what is the optimal way? Let's say he jumps. Let's say he is this is the grade 2 1 2 3 4 5. Let's say he jumps from this index to this index. So he will gain the value of 4. Now again after that he will jump to this index. So he will gain the value 5. So he has value 4 plus 5. Now two operations are done. The last operation he will stay at this index. So he will get another value 5. So the total answer is 14. So the answer is 14. So this problem is quite easy. Uh, it is quite easy for a problem of G level. It could be around E or D level. Only thing, the constants are also quite low. The N and M, the H and W could be around 50 at max 50, and the only thing is K is could be 10 to the power 9. K could be 10 to the power 9. If let's say K is also less than 50, then we can do some kind of recursion with DP with I comma j comma I comma j comma k. Okay, from I comma j comma k we can move to any neighboring cell. Let's say Ni comma Nj comma k minus 1. Okay, like that we can move to, and we'll do this kind of recursion to find the maximum value till k becomes 0. So this will also work if there is a cycle, if we are moving in cyclic order, because we are decreasing the value of k. So we will not be going to the same cell with same value of k. So this recursion will work uh, if the value of k is less than 50. So order of n into k, n into m into k solution would pass. But here the value of k is 10 to the power 9. So we can't really do this kind of recursion. So how we can optimize this code? So the first observation and the most important observation here is that, let's say we arrive at one cell which has the maximum value in the grid. We arrive at one cell which has the maximum value in the grid. Then we there is no improvement. If we move from this cell to another cell and come back, we can stay in the cell and we can maximize the total value. So the observation one is that if we reach at the maximum value cell, we will be at this cell and will not go to any other cell. So let's say and the second observation, this is the first observation, I am not writing, I have told you what is the first observation. Second observation here is that from the starting cell, what is the maximum number of moves, what is the maximum number of moves it is needed to get to the max cell. So the total the maximum number of moves is order of n into m. I think this is possible with less than this also. Order of n plus m, I think it will be the most optimal case. But here I am taking that in order of n into m number of moves, we can reach from the starting cell to the maximum value cell. Okay, so when we reach at the maximum value cell, let's say we have reached the maximum value cell at p moves. Okay, we have reached the maximum value cell at p moves. Then total number of moves remaining will be k minus p. Total number of moves remaining will be k minus p. So we'll get k minus p into the max value. K minus p into the max value. We don't have to move further. Okay, so we can use the our recursion code order of n into m into k, and we could use k as minimum of k and n into m. So we can use minimum of k into n into m, because we are, it is guaranteed that after n into m moves we'll reach our maximum value cell. Okay, when we reach the maximum value cell we will not move further. So let's jump into the code. I will explain the approach along with the code, you will understand it better. So here we have initialized one dp of 51 n into 51 into n into m to 2500. Okay, now and here is the maximum value. Maximum value is the maximum value in the grid. Okay, now this part is for the recursion. Now if the I, j and k, okay, so the will start from at k equals to 0, this is small k, and our large k will be the total number of moves we can make, total number of moves we can make. Now this small k could be at max, the small k, okay, what is happening, the small k could be at max n into m, right? And after that we will get k minus k into k, this one k minus capital K minus small k into maxi number of value will be added to this. Okay, now let's say if k greater than n into m, then what does that mean? That we arrived, we have taken greater than n into m number of moves, but we have not reached the maximum. So there is no way that will be optimal, because the optimal answer will be to reach the maximum value in least move possible. Okay, that is the most optimal case. We have to reach the maximum value with least move possible. So when I am discussing this, I think this could be solved better using VFS kind of thing, like the we can do VFS to find the minimum number of moves we can reach to the maximum value cell. Then we can take the take, instead of n into m we can take that as the upper limit. Okay, that could be one optimization we can do. Then I think this value could be order of n then. Okay, so overall time complexity, instead of order of n square m square, it would be n square m. But according to the time complexity, our n square algorithm will also succeed, also get accepted. So we are not doing that here, but you may do the optimization, right? Now here we are iterating over every possible neighboring cells. Okay, now this means that we are moving only to left or right, we are not going to any diagonal elements. Now if the element, if the neighboring element is the maximum element, we are returning the value as total number of moves remaining into the maximum value. Else if this element is not the maximum, then we have two ways, we have two possible ways. I have get some wrong answers when I am assuming that if the I comma j is the neighboring element is the not the maximum value, ni comma nj is not the maximum value, I am assuming that will obviously be moving from ni comma nj to any other cell, let's say ni dash nj dash. Okay, but this is not the case. Let's take one example. Let's say we have something like 1 10 10 100 uh, 1 1 1 1 1. Okay, and let's say we have value at k equals to 3. Then the what is the answer? Answer here is that we'll jump to this cell and we'll stay at this cell 3 times, so the answer will be 30. Okay, but this is not the maximum cell, right? So we can the possible solution is that we are moving to the neighboring cell, or we are moving to the neighboring cell and staying there. Okay, so this recursion will be that we are moving to this cell, but we will move from that cell, and this means that we are moving to the neighboring cell, but we will stay to the neighboring cell till the end. Okay, why we are doing that? The recursion I comma j guarantees that we will be moving from the I comma j cell to any other cell. That's what my code does. You can improve the code also, such that this condition is not needed. But my code thinks that if we are calling the recursion I comma j comma k, and k is not k is less than k, then we are obviously be jumping from any other neighboring cell to jumping to any other neighboring cells. That's why we are taking into consideration this case also. But this code could be improved a lot better. You can try to optimize this code and improve the code quality also. I hope you understood the explanation. Why the two main observation is that if we are at the max cell, then we will be staying at that cell only, and the second observation here is that we will only be needing order of n into m number of moves to reach the maximum cell. I hope you get the explanation. If you have any doubt in any part of the explanation or code, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel, and also share among your peers. Thank you.